look at factoring a difference of squares. And then they're going to look at two methods for it. So there is a method for factoring a difference of squares. The method is essentially finding out that this is a difference of squares. So to be a difference of squares, difference refers to subtraction. So we need to be subtracting. It also needs to be a binomial. And the binomial, what that means is there's really just two terms in here. Okay? So the quickest way, and this is the shortcut to do it, to factor a difference of squares, is to essentially just take the square root of the first term and the square root of the second term. Okay? And what you're going to do is you're going to have two sets of brackets.
So 2x plus 1, then plus, and then it'll be minus.
Exactly. So the root of 4 is 2, and the root of x squared is x, so we're left with 2x. So that's going to be the first term in both. Okay? And the square root of 49 is 7. And you're going to get a plus and a minus. And that's it. You've now factored it, and we're going to go about finding the actual roots. But let's say you don't recognize that it's a difference of squares. It's very possible you come to a test and you're sitting there going, I don't know how to do this. There's another way you can do this using your product sum method. You have to recognize something else, though, in this case. And sometimes you might think it is easier. Some might see it as harder. But the idea here is, let's write this as a standard form. So I'm going to write my standard form above it. I have my ax squared, because that's when we use product and sum, is when we're doing a standard form, plus bx, I forgot the b there, and plus c. Okay? And let's kind of define what each of them are. Our a value is 4. Our b value, there's really no power of 1x. There's nothing there. And our c value is negative 49. Okay? So there's no b value. It's simplified if you leave it out, but I'm actually going to replace it. So I'm going to make this formula a little longer. If there's nothing, in math, to represent nothing, we use the value of 0. Okay? So I'm going to say plus 0x minus 49 equals 0. Okay? Still the exact same equation above, but now the b value is 0. So now if we're using that product and sum, for our products, we're looking for two numbers that multiply to 4 times negative 49. So I'm going to figure out what that is. Okay, so two numbers that multiply to that. And those same two numbers are going to add to our... I should have used something a little nicer here. They're going to add to our 0. Sorry. That's 196. Perfect. Yeah, okay. So negative 196. Negative 196. Okay. Lots of 6. Okay. Negative 196. So I need two numbers that multiply to negative 196 and add to 0. I'm going to show you a theory here. Essentially, in order to have two numbers add to 0, one needs to be a positive, one needs to be a negative, and they need to be the exact same values. Okay? You can't have like positive 4 and 2. That's not going to work. So they need to be the exact same. In other words, I'm really looking for two numbers that are identical, or think of it like the roots. I'm looking for the two roots of this. So the two roots here, it's going to be a little different. Our two roots, there's not quite a whole number root to 196. Let's pull it out. Oh, is it 14?
Yeah.
Oh, never mind. I did pick a nice number. Look at me. Oh, sorry, wrong one. 196. Yes, I got that. Oh, good. Okay, sorry. I thought I chose a tougher number. Great. I'm glad you're better at math than me. Okay, so 14 works out perfect. In order for it to be a negative, one of them is going to have to be a negative, right? Which makes sense below because negative 14 and positive 14. Great, so they work out. So now when we do our product sum, we write our 4x squared, and we split these. We have a negative 14x, and we have a positive 14x, right? This is how you guys do it? Great. Negative 49 equals 0. And now I go through the exact same process. Here, I can common factor out the number 2 and the letter or the variable x. So I can take 2x out, so I'm left with 2x minus 7. Okay. And here, I can factor out 7. Yeah, I can take out positive 7, which would leave me with 2x minus 7. And if you recall, the two brackets are the same. So we have 2x minus 7. And then the leftovers are 2x 7. Okay, a little more work when you don't realize that it's a difference of squares, but you still essentially get to the exact same answer, and you're still using something you're very, very familiar with. Oh, I forgot to actually find the x values. Since it's already set equal to 0, or the x-intercept values, we set each bracket equal to 0. So in order to do that, we have 0 equals 2x plus 7, and 0 equals 2x minus 7, and the goal is to just isolate for x. So when I move positive 7 over, I'll get negative 7 is equal to 2x. When I move negative 7 over, I'll get positive 7 is equal to 2x. Okay? So my x-intercepts are negative 7 over 2 and positive 7 over 2, which I think is essentially positive 3.5 and negative 3.5. Let's bring up a little graph here to help us out. It was 4x squared minus 49, I believe. And our x-intercepts, negative and positive 3.5. Okay, so exactly what we're looking at.